Algebra 2, Lesson 112, Quadratic Inequalities Less Than. This will be a really quick lesson because it's just the opposite of what we did on Lesson 110 of Quadratic Inequalities Greater Than. So if you haven't watched this video yet, go back and watch this one. Go back and watch the video for 110, and that'll make this one, 112, much easier. So, I'll go straight into an example problem so we can see the difference. If you remember, our greater than inequalities formed disjunctions, which means that they went apart. Our less than quadratic inequalities are always going to form conjunctions, meaning that they join together. So first example, we've got x squared plus 3x minus 4 is less than 0, and the domain is in the set of reals. Whoops, that was a little crooked. Okay, so we start off by factoring this into a set of parentheses. We're going to get x and x. The last number is a negative, so that's going to be opposite signs. Factor 4, we've got 1 and 4, and then 2 and 2. 1 and 4 will add up to 3, or subtract to 3. So 1 will be negative, 4 will be positive, 4 and 3, yeah, that works. Okay, from here we just have to solve for our x values, which are going to be, let's see here, we'll do this in black. So the opposite of positive 4 is negative 4, and then the opposite of negative 1 is positive 1. So then we go to our number line. We plot negative 4, we plot positive 1, and we draw our dots, which, since there's no equal to sign, these are both going to be open dots. Now this is where it differs. So everything we did up to this point is completely the same, except for the very last step. So since it's a less than inequality, we're going to form a conjunction, which means we're going to connect our two dots. And this will always be true for less than, right? And then if you remember with greater than, we would have drawn the lines away from each other, forming a disjunction. And that's the only difference between these problems on lesson 112, is since it says less than, you can join them. You form a conjunction. We'll go ahead and do one more example, just in case you still need to see it. Let's say we've got, hold on. We've got negative 10 plus x squared is less than 3x, and the domain is in the set of integers. Okay, so for this example, first thing, our quadratic is out of order and we've got some numbers on the wrong side, so let's go ahead and correct this by subtracting 3x from each side. And then we'll rearrange the left side to put it in descending order. So we'll put x squared up front, minus 3x next, and then last will be minus 10. That is all less than the number 0. Then we have to factor this into two sets of parentheses, x and x. Last term is negative, so a plus and a minus. And then what factors of 10 will add up to negative 3? 2 and 5. If 5 is negative and 2 is positive, we get negative 3. That is less than 0. Now we solve for our values of 3, or our values of x. Opposite of 2 is negative 2. Opposite of 5, negative 5 is positive 5. We draw our number line. Wait, is this? Yep, it's just like that. Okay, and then we go to negative 2 and positive 5. Now you'll notice that this is not a less than thing, and then our domain is integers. So we don't have to put open circles at negative 2 and 5. You can if you want, but since our domain is integers and this is a less than, we're going to form a conjunction. So we need to pick every single integer in between negative 2 and 5. Again, I'm not going to draw a solid line because of my domain. So I'm going to put a mark at negative 1, at 0, at 1, at 2, at 3, at 4. So 1, 2, 3, and 4. All of these get a solid closed dot to show that those are the values that we're using. Right, and then that is it. This is my final answer right here. If I wanted to, I could put open circles at negative 2 and 5, but it's not necessary. That's all there is for this lesson. If you guys have any questions, let me know on Moodle, and I will see you in class.